So let's use the intermediate value theorem with a practical example. So if I'm given this function, x cubed plus 2x minus 1, and what I'm trying to do is I'm trying to find a root of the function. And roots of functions are a pretty standard algebraic technique, and they're used even in industry and all kinds of stuff. So this is kind of an important thing to find. So if I want to find the root here, or find the 0, in the interval 0, 1, well, what I can do is I can test the endpoints of the interval. And if one of those endpoints has a negative output and one of those endpoints has a positive output, I know by the intermediate value theorem that I'm going to have to go through those inputs to 0 since I have a continuous function. So let me take a step back and say, a lot of times we use IVT to abbreviate intermediate value theorem. And I also made the assumption this was continuous, and I did so because it's a polynomial function. So what I would like to do first is find f of 0. Well, f of 0 in this case is 0 plus 0 minus 1. And then f of 1 is 1 plus 2 minus 1. So that's 2. So what I have is I have some point here and some point here. And so what I would like to do is, so I know a little bit more about this function than what I'm sort of letting on here, but it looks something like this. You could plot it, but let's just assume it looks something like this. So we know that it has to have a 0 here. But then you might ask yourself, how do I find that 0? How would I possibly find where that 0 is? And the answer is there's a little trick to finding it, but the problem is you may not find the exact 0 you think you're looking for, and I'll talk about that in a minute. So there's this method called the bisection method, and what that means is that what I'm going to do is I'm going to take a look at these 2 points, and I'm going to say, all right, I know that it's got to be between these two, so I'm going to cut my region in half. So I'm going to cut it in half. And so then I'm going to analyze the function output here at that point. So in this region, it's positive and positive. So I know that the root that I'm looking for is not in that region. So I know that it has to be in this region. So now I've just cut my interval in half. So I do the same process again. I cut it in half. Well, now these are both negative. This is positive and negative, so I cut it in half. Well, now I know this is my region, so I keep cutting it in half. And you keep cutting it in half until you bracket. So this is called a bracketing method. You bracket around it until you converge on the point. And that's a really useful technique. The issue is that it can sometimes miss zeros depending on how your interval is chosen. So consider this case. All right, technically speaking, I have 5 zeros. But if I analyze the point here and here, then I'm going to choose this region and I'm going to throw away that. So I end up throwing away 3 zeros. And then I keep doing it. And so now I've thrown away that one. And I'm going to converge on that 0. But I might have accidentally converged on this 0 or the other one. And so I don't have a guarantee that I'm going to get all of my zeros in there just because of that. So be careful when using the bisection method. Just know that it will get you an answer, but it may not get you every answer in that region. So you might need to be a little more careful about how you choose your points.